That should be okay. Yeah. So perfect. So as I said, I think that should be good for my introduction. So for those, I know there are new people who don't know me. Also, there are people I don't know, and so there are few people that at least we know each other, but we'll keep on knowing each other as time goes by. So getting to our today's short and brief webinar, as I'd said the outline of it, we are going to first start by looking at different definitions that we have gone through, we have seen before, just to refresh and see. And the first definition that we'll be looking at will be data science in particular. I think this forms actually our topic of the day. So there are many definitions that are okay. Thomas is saying is coming in. Okay, let's hope he'll be joining. He'll not have problem to join us. Okay, so good. You say? So as I said, there are various definitions that have been put forward by different people to capture what data science is. But from my side, I think what I thought of that will capture this well will be it's just a study that is aroused from curiosity in any given field. This can be in the field of health, it can be in the field of whichever field that people, agriculture and things like that. So you want to get insights from it, and there's a lot of data that is streaming in. So how can we be able to use the data and be able to process and analyze and get meaningful information from it? And actually, to me, actually what I view it from it's just actually an extension of what we normally have been doing on data analysis, but then now including bringing in on board other forms of analysis that we're going to look at, other forms of new technologies that are coming, have come on board to make the derivation of insights and things like that quicker. So the next definition that we'll be looking at is artificial intelligence, which is basically reproduction or yeah, reproduction of, like, having computers to reproduce what human beings can do. And yeah, and actually it carries down almost everything, so that we can see, is it possible to have computers do things in a better way than we human beings can do? Can they reason as we reason and things like that? So basically that is what artificial intelligence involves. And then lastly, of the definition that I want us to look at is machine learning. And machine learning is just a set of tools that we use to learn from data. But then what is more interesting about machine learning is that we don't have to write the algorithms as we normally do. This should be this should be algorithms that that by themselves they're able to fine tune themselves and learn uh, patterns within the data set without necessarily programming it step by step, like we normally do. If this does this, this should happen. No, like having the algorithms to be in a position to be able to train themselves. And if we were to look at this in a bigger picture, like in the terms of mathematics, the subsets, like all these are related, the three terms are related, and you find that all the three fall under the umbrella of artificial intelligence. So you find so machine learning is a subset of artificial intelligence, and also data science is a subset of artificial intelligence. So they all fall under one umbrella of artificial intelligence, but then within them now we have the different subsets of it all. Um, Getting down, so we'll realize that data science is a multidisciplinary field. It doesn't just come into one. It's not just a specialization on one thing, like let's say statistics, which is basically like we'll be following the line of statistics. So this is a combination that brings on board various fields, so that at the end of it all, it forms one concrete field that at least it can be adapted to various areas. So if you look at the diagram that was prepared by Brendan in 2012, at least it gives us a clear picture of how data science it's in itself quite multidisciplinary. And if you look at it, it's at the heart of the various things that happen. So it involves, so for you to have data science, it involves visualizations at some point, which carries quite a certain proportion of it. It involves statistics. It involves pattern recognition. And then it also involves neurocomputing, machine learning, as I'd said. It involves artificial intelligence. It involves data mining. So these are different aspects of things that we have been having them, but then mostly people have consider and specialize them in individually as areas of expertise. Then we have database. We have the data has to be stored in databases and things like that. So all these, if you combine them together, like at least each aspect, if you're to become a data scientist, in one way or the other, at least you should have some knowledge in at least each and every, because it's an intertwine, it's a mixture of all these, that at the end of the day, at least you can be able to do well and specialize in that thing. Then in the outer board, we find that some of the areas and things that are important to consider and are useful in the data science picture, so which will involve, if we start from here, it starts definitely from the point of questioning yourself. So we have data that is flowing in, but then we need to start a point of what problem do we have ourselves, what are we curious to know about. Then we get to problem solving. How can we solve the problem? Then you analyze the business market. Will whatever we have to do at the end of it all be able hello, sorry. Good. So we have business, and so whatever we are doing, are they fitting the market? What is required in the market? And we have the business strategies. We have domain knowledge, and the domain knowledge is, well, in the area that most as data science come in, most people come from a specific domain. Like, let's say your area of specialty is agriculture, or your area of specialization is maybe a medical expert, so you want to apply data science in that field. So domain knowledge also comes in handy. Then how you communicate the results that you obtain, and presentation. So in itself, so here what in particular I wanted to capture is that data science is not just one thing. Like if you're specializing in databases and data processing, you call yourself a data. No, it's actually a combination of different fields, at least having knowledge in different, now combining them into having at least some knowledge. And if you're in a specific domain expert, it becomes even better when you have to specialize in it in that field. Then we have different aspects of data science, and some of the aspects that are clear to see, well, sorry, some of them will be have been captured before, but some of the aspects that clearly come out is, now we have data science. We have the area of statistics, and as I had said earlier, data science is actually, like we'll say, well, it's something that had been built from data analysis that we had, which statistics forms a very critical element of it. Then we have advanced computing, or just computing. It forms also a very critical component of it. We have visualizations to easily communicate information and patterns that cannot easily be seen from the massive data. We have hack mindset, ability to be able to use tricks and tricks so that we can be able to achieve results in an easy and efficient way. You have domain expertise, data engineering, being able to see how we can move data from from storage and things like that. That is the area of the database and things like that. You have scientific method. You have mathematics. All these are like the machine learning aspect. I think all those methods that have been built up, they are all like on the area of mathematics. So mathematics forms quite a fundamental part of it. So all in combination together build up what data science comes in. Now quickly to jump into like the aspect of, let's say, machine learning as we had defined. We're going to look at a few highlights of what are the branches of machine learning and what are the examples of it. And machine learning is divided into well, at least three. It's actually, so far there are three, but then I'll focus on two. That is supervised machine learning methods and unsupervised machine learning methods. So we also have semi-supervised, which now comes to mix the two. Like you have the two of them combined. And basically, supervised machine learning method is where you want to do a prediction, or you are studying a data, and the data that you're studying in, and want to perform or to build a model of prediction. You have the data is labeled, and what I mean that by saying that the data is labeled, at least you have the outcome of it, or of it is known. A good example I can give is on, let's say, on if you want to know on credit rating, or on default, let me say fraud detection, for example, where it's either someone is found can defraud, or he's okay, or he's guilt, or he's not guilt. So at least we already know the outcome. So that falls under this. So the outcome of it all is known. And examples of supervised machine learning algorithms are, for example, one, the normal linear regression approach that we use it, so which is used to predict variables, or when the predictor variable is continuous, is a continuous case. As for instance, say you're trying to predict what will be the income of people based on various factors. So the income, we know, is a continuous variable. So linear regression can be one of the algorithm to consider. Number two can be a case of logistic regression as well, but then we'll be considering binary classification problems. Then you can get to, these are now the elementary one. You can get to other advanced methods like support vector machine methods, which can be used also for classification and also for continuous variable as well. It's quite adaptable to two. We also have other methods like random forest. You can talk of decision method, decision tree method, all fall under supervised machine learning algorithm. Then on the flip side, we also have the unsupervised method. And on the supervised method is when you have a data and you don't have the predictor, you don't know, like the predictor is unknown. You want to predict as well, but then you can't really tell that this is the outcome. So it's up to getting into the data, and then at the end of the day, you can now mine inside the data and be able to at least segregate or make classification of it. So what it basically is, there are algorithms that have data points, that work on data points that have a known outcome. And examples of this, a good example is k-means. So you have a data you want to segregate, let's say a population, and you want to segregate into different regions based on similarity of characteristics. So k-means can come in handy. So at the end of it all, you can get, say, this person belongs to this group, this person belongs to group X, and this person belongs to Z. So it's up to each to study the pattern, then at the end of it all segregate into, let's say, 3 groups or 4 groups, and things like that. Another algorithm that is applied in this is KNN, K nearest neighbors, based on the neighbors around. So you spot a specific data point, then look at the people around who have similar characteristics to the specific data point you have selected, then at least be able to classify based on the neighbors which are around it. The K is the number of neighbors that will be around there. And then here we also have advanced method like a priori algorithms and things like that. So basically, okay, these are the main classification of that is supervised methods and unsupervised methods. And the differences are actually the issue of labeled data. The label one has known outcomes. The unsupervised doesn't have an the outcome is unknown for the predictor variable. And then I think another difference. So there are a number of differences, because if you look at even when you come to giving how to split the data, when you come to supervise, at least the data has to be split into two. The data has to be trained, and so you have the training data, and then you have like we'll see after, and you have the testing data of it. But then when you come to unsupervised, yeah, you just give it data, then it's up to itself to just come in and train the model by itself and give the prediction from there. Assuming that is clear, I hope that is clear to that point. Then we move on to what exactly is done when it comes to training of algorithm and these machine learning methods as they work on it. So I want to give two case studies are like two examples or just a good explanation of what happens exactly, especially. So this one will actually apply more to the supervised machine learning algorithm. So given a data set, you're given a raw data set you want to work on. And for example, here, assuming this is just a sample data set of it that we have, and we want to, at the end of it all, give a prediction. And let's say, for example, the last column is our predictor variable. Well, should not be the best predictor variable. We have a predictor variable that we use this as our variables. There will be our variables to use for the prediction of the method. So what happens is the data is required to be split into two. That is training data set and the test data set. Training data set is just basically the data set that we use to build the model. And then the model has to be tested of if it's good or if it's not good based on the test data set. So you and these data sets are split from the word go before you begin your analysis. So you put aside some data that you use for training so that the model will be tested on a completely new data set that that it has not been trained on, to avoid so that you can test issues of, let's say, if the data is overfitting or it's underfitting, or if it's perfectly fit, it's performing well. So normally that's what is done. So, and what is normally done when it comes to this, you split your data in percentages. So the training data set should be of a good percentage. So normally people use 70% for the training data set, and then for the test data set, you use around now the remaining percentage, which is 30%. Alternatively, there's an option you can decide to use 80% for the training, then 20% will be used for the test data set. So it depends with your own preference. 70% is not like this must be used. You can use, but at least a minimum normally is, I think 70 does. It's like a default, if you are to say in quotes. But generally you can change from 70 to 80 or 75 and 25. It's up to you to see on what to do. So there are actually two methods that you can use to do this. So the first one is called holdout, and this is the most naive method that most people use, or anyone has to be introduced to these users. So you just get your data, maybe you have 10 million cases, take 80% of it for training the model. Then after you've built the model, you've done enough tuning of your parameters, and you think, oh, I think this model is now doing fairly well. Then you now take the model and test it on the 20% that is remaining and see, is it still, how is it performing? Is it performing well, or is it performing bad? Is it a model that we can adopt or not adopt, so that if it's good enough, it can always be deployed. If it's not good enough, then can think about it. So if you just take your data, split like that, and then after this, after you've tested, and then it gives an accuracy, for example, of 80%, and then 80%, and you're happy with that prediction, and you call your work done, then what you'd have done, you'd have used the holdout method, and that would be it. However, as I said, it's a naive method. Reason being, you see, you just took just one sample of it, and you want to use that to conclude, like you've not considered different variations and things like that. So the model might not be very good at some point if tested with other data sets. So normally, so there is another method that also has been suggested on, which is called k-fold cross validation. So that is the next method that we are going to consider. So k-fold cross validation method is actually using the same concept, but then we want to use something like do it repeated, repeat several times, then at the end of it all get an average of it. So have different variations while training it, then at the end of it all we can be able to use an average of like the average now be represent the average of the model will be the one that we use it. So for this case, if you're using a k-fold of 10, which is normally the most used value, like 10, so you do so as you're going to see, so you split the data like this. So for this case, I've just given a k-fold of 4, so my k is 4. So what you do is like the first one you do as we did for the holdout method. Take, as you see on the cross validation of the output one, so split into 80 and 20, get that, then do for 2. So for this case now, it's you now take a different portion, so it's not like the first one exactly, so you're taking a different variation of the data, and then now build on that. Then from there, take number 3, you build on it, so you're having like this is another holdout again, then validate number 4, you do it again like that. So this might not be exactly like you picking specific variable, but this can be done like through randomization. Normally that is what is done, so it will not be specific like this portion as it moves, as I'm showing it on my slides, because you always take like it should be random, like keep on taking values randomly, selecting if the 20% will be taken randomly from the data set, the 80% also be random, and something like that. So at the end of it also we have, as I said, hold out how it is. So here I had one of them, but now here we have 4 cases. So if k is 4, so we'll have an average of 4 of them. So at the end of it all, the results of this, the model of this will be more representative, and well, normally it works better than the first one because you're only considering one case. So this actually comes a lot of advantages. It outweighs the advantage of it outweighs the first one. So this is called k-fold cross validation. It's quite doing much well. And what has been seen from different tests and what I've also experienced is that if you do just a prediction and on holdout and you get a prediction of, let's say, 90%, if you get to cross validation, most of the time at times you can do on cross validation and you realize the prediction comes from 90 and even can get to 70. And so that tells you how bad your model is, how your model is, and like it's not that reliable using just the holdout. And for those who have seen cargo competitions, things like that, if you rely on holdout, well, be sure you'll never be among the top cargo competitors, because at the end what they would rate will be using the cross validation and other advanced methods. So if you're using cross validation, normally it's always remains stable to the R. It doesn't, the prediction or the score of accuracy that you have will still remain high.
Okay, before we continue, maybe I have a question.
Okay, you're welcome.
So you said that you're getting the means. What are these means that you're getting?
What is it?
The means of what are the means of what? Like we are using, like, for example, k-fold. You're getting means. You have not mentioned which means exactly.
Okay, the means of, so here you see, so when the algorithm is built, okay, for the cross validation, so before them, like this data is, let me just see, will tell you what happens exactly. So when a function of that will do this is, we will have to create a function that will do this. So it will take various combination of this. So at the end of it, or when you're training, when you're doing this, I don't know if I would have explained this, would have been easier. So when you're training your model,
then you can proceed. You can proceed
considering all. Yeah, but then when you're training your model, so as I said here, so the model is trained on the training data set. So when it comes to, when it's the data is being, or when the model is being built, it will be built on those all 4, like it will be considering now all those variations of 4. Like the k, if it's 10, if it's whatever, it will be considering all those variations. And then when it's testing also, it will not be testing on the few that was selected. It will now be considering taking care of 4 tests that are now also.
So for example, if you are dealing with accuracy,
yeah,
you're getting the average of those accuracies.
So the overall accuracy that will be given will now be considering the average of all those combined permutations of it.
Okay.
Yeah. But then, so on model fitting, so what happens exactly? So I have here is, I hope this diagram will help me explain that. So you have your training data, 80% of the data is here. Then, so the data is split into 2. You have X train here will be the 80% of the data that you have. Then Y train So X normally is like from the I don't know if I can, yeah, it's from the training data set here. So X train and Y train. So if you come here at the top, so when you have, let me use the first one here. So the first part of here is called X train. Then this one is considered as Y train. No, sorry. This is the first one is X train, which will have like you see the data is, I don't have the predictor variable here, but assuming you had a predictor variable here, yeah. So this predictor variable, the first part here is X train data set. Then the predictor column here that will be here will be called, it should be somewhere here, let's see. So the predictor column here will be the Y train. Then when you come here on the other side here at the end here, you have two variations as well. So this will be there. This is the prediction. So you have, that is X3, yeah, on the test. So you have X test and Y test as well. Good. Hoping that is clear. So when you come here, so you have, when you're training it, so you have what you'll be training on, and then you'll be telling it that when you train this, these are the expected results. Right. So using a model like for here, this is just an example, KNN, K nearest neighbors, but it can have, you can have K means, it depends with which model, whichever model you're training on it. So this model will work on this, and you're telling it that when you run the patterns that are here, how do they match to this? So this, how are they matched to this to fit that? So you fit a model should be fitted based on the algorithm that builds on that, and then it builds a model. So when the model is built, then it gets to the test data. So when it gets to the test data now is the one that is just to validate the model that has been built, because it was built on a 80%. So how well can it be if given a new data set? Because when a model is built, it should be used on a new data, something like that. So test data comes in. So you bring the test data and then see on this model how well does it perform. Then you get the prediction. So, and this is where we get if it's the accuracies and other metrics of or that measures how well the model is performing, like precision and precision and things like that will be checked on that. Then from there, so after using the model, you get to check out its accuracies. Then another thing that we look at is the error metrics. So the error metrics here, these are just how to check how well is it. So we have the Y test. Y test is what is expected. You already have the results, and then Y predict is what was predicted. Then so you want to see if it was, the prediction was yes, let's say this person is involved in fraud here. Then does the model also predict that he's involved in fraud, something like that. So this is what we have in our data set, in our test data set, and then this is what was predicted from the model. So from there we need to have error metrics that will check how many were predicted correctly, how many were not predicted correctly, and things like that, so that we can tell how well the model fitted well into if it's good for deployment and things like that. Then quickly to wrapping up, it was I think it was a quick preview of it. Wrapping up is applications. I think applications are quite real, and they are things we are seeing in our real world every day. And a good example that we can use that hit everywhere is application of in the election, like election of Obama in 2008 and 2012. We had 1 million people who through the Facebook things when they got access to it. It was Cambridge Analytica.
Cambridge Analytica.
Yeah, I think it was on news everywhere, and that was a big deal. That while I hope it's, I don't know if it's true, but now that it was everywhere, it suggests it was one element that played a big role in his campaign through Facebook and things like that. Another example is Netflix. Is it called Netflix movie recommendation? You know, Netflix just grew to a big company, like a multi-billion profit-making company, just based on application of data science and artificial intelligence on recommending people new movies, the pricing based on how people are buying and things like that. And this has been applied the same way to Amazon, eBay, and all those. It has become a big marketing strategy for even for Google and all these things. So data science, its applications are real, and And another example that I can give is and I have some friends who have been working on it, is on chatbot. Like I see people are working, like if you're talking, calling something like Safaricom, at times you receive response, you're not really talking to someone, or you're texting, you're not really talking to someone, but it's a machine that is just reading things and trying to respond to you, and at some point responds correctly. And well, that helps in reducing workload and doing things like that. Yeah, in a nutshell, that marks the end of the presentation. What I want to do in like 5 minutes is give a very simple example. I didn't want to give a complicated one, just a simple example of an example of this using KNN, which I use here. So it's just a simple example, and I think most of the things I will not even show. I will not go into details. It's just showing how this can be applied and how it looks out in reality. It may not apply everything because I had to just a simple one. And it's a supervised machine learning algorithm, which uses KNN or K nearest neighbors. And so for this case, it's on customer churn. So actually, like the goal of this is to see customer churn is when you have people in. We have, like for example, let me use the Kenyan case. We have Safaricom, we have Telcom, we have Airtel. I think those are the main telecommunication agencies we have in Kenya. And then now we have, so me as a customer and you as a customer, maybe we subscribe. I subscribe to Safaricom, you subscribe to Telcom, and something like that. But we always normally have people switching from one network to the other. So today I'm in Safaricom, but I feel no, Safaricom, I think I'm not getting worth of my costs that I'm incurring. Then you think, oh, let me switch to Airtel, or you're in Airtel, you think I want to switch to Telcom, something like that. So that is called customer churning. So one of the application of it could be, how can we use the information that they collect from our phones and from their customers, each telecommunication, how can they predict that this customer is likely to change from being an Airtel customer or being a Safaricom customer, and then will be changing to another line. So we call it customer churning. So how can is that something that can be can you predict something like that? Then if it's predicted, you know that this guy is likely to move, then normally they start giving you incentives. They start giving you I don't know. They start giving you offers, like the one that they give currently, the bonuses. You charge a little credit, they give you more bonuses and things like that, just to make you remain as their customer and things like that. So for this case, you're going to use a small data set here. Well, just to give an example of that. So our telecommunication, well, this is not real data. It may not be real data, but it's from so we are going to look at, so this is data, and it will be having the state where you live in, like you live in Kisumu, Kitale, area code, phone number. It have your international plan, your voice plan, number of voice messages you have, total. Like this is just basically the data they collect from your phone at the end of it all. So it can have as many columns as you can. So here you can see the columns are more than that. So for just a preview, you have total evening calls, total. So like the variables are so many and things like that. But then basically based on what happens with your phone, relationship between us and our clients. Then so to do this, so the processes are normally just as data analysis. Before you go to doing a linear regression, you normally have to clean your data and things like that. So there is pre-processing stage, and that is what, like here we are trying. The first thing you're trying to do to remove extraneous columns that you think they are not of value to this analysis, and things like that. So you do pre-processing activities, and pre-processing activities. So for machine learning cases, there are some of the things that you always do. If you have continuous variable, for instance, categorical variables, most of the time you need to convert them to dummy variables so that they can be used well. As usual, as we know, there is what we call things like normalization of your data. You want to convert to normalize all your variables that you have, so that you don't have some having heavier weights than the other one. Especially this helps a lot for the sake of, different columns have different units. Some is, let's say, body weight. Like here we have calls. You see, some have like area code. Well, I don't know. This is not something that we use, but so you see like time in minutes. Then the other one is total calls. So if we cannot compare these two columns or use them, the two columns, they will be biased because this is time is in minutes and this one is in days. So using such, if you use it in prediction, no, the prediction will not be correct. So we need to normalize these variables. So that at least we can be measuring them in the same unit scales or something like that. So this will fall under pre-processing data and cleaning. There are a number of things that you can do, as we all know. So then after you've done pre-processing of your data, so like here we just removed. Another thing we did is converting those ones that have the ones that are converting, what like binarializing, binarializing the columns like that, like just to ensure like if one is categorical, we have to make it if categorical, it should be in 0, 1, something like that. Now that I said 5 minutes, I just want to rush. So that is just basically pre-processing, which there are a number of things you do based on the whatever work that you're doing. So they keep on buying just data cleaning. It's not the same as cannot be reproduced from one task to the other. So for this case, the whole thing is, I said, is churning. So the predictor column is like if you're likely to if it's 0 here, like the last column is 0. I don't know if it's shown here. Yeah, churning. So if it's 0, it means your customer you're likely to remain is still going to be a faithful customer. You won't change. Then if it's 1, you will not be a royal customer. You want to change, you want to change to the next and go and find what does. So if that is what is supposed to be predicted there. And for this data, I said is a small data, just a toy data set. For example, so you see the number of columns here are it has not number of columns. So the number of people who are going to be retained by the company is 4,293. Then the people who are likely to change to another network is around 700, and this raises a question. If you look at the proportion, the proportion matters a lot. Well, that should be a discussion of another day, but we have to consider issue of balance. It's called imbalanced data. It needs we need to think deeper than that, but here we just assume the data is okay. So you get to model fitting. So here, what I've done here, when you see Y data and X, Y data and that is what I showed on model fitting. X data test, the training and that. Then here we get quickly to the classifier. So here I'm using Python. Sorry. So the Python here using scikit-learn package, and for this case I used the number of neighbors, like using the number of people around you, around a specific customer is 3. It happened to be the optimal number, as I will show below. So the model is fitted here. Then when you do the prediction, guys, using the accuracy one, I didn't want to use the other methods. So these were the results here. So when you use K of 3, using 3 people around, considering 3 people around each individual, it gives an accuracy of 94%. So it tells you like it predicted when you come to all these on the test of all of them. So like 94% of the people were predicted correctly. If he was to remain, he was remaining. If he was to change, 94%. Like only it missed out 6% of the people who were of the prediction. So the model is very good. Then if this is just checking, I tried with 2, it gives 91. It drops with 3, it gives 94. As I said, with 4, it gives 91%. So you can see around 3, that's the optimal place. Yeah, so for this case 3 is the optimal number of K. So K should be 3 and then now and things like that. Good. Now these are other things. So I want to stop there and ask if there are any questions. I'll be happy to answer. Thank you. Okay. Good. I hope I was clear. My voice was coming.
Steve, thank you. Hi, Steve.
Hi.
Thank you for that wonderful presentation.
Oh, thank you.
I just have some few quick comments to make.
Well, you're welcome.
Can you hear me?
Yes, I can hear you clearly.
Yeah, so at the beginning you had some detailed description of what data science is, and it's so many things.
Yes.
Yvonne,
Yes.
maybe should you can Yvonne.
Yes.
Just continue then.
Okay, you can hear me? You can all hear me?
Yes. My side, I can hear you. I can hear you from my side.
I can hear you too, Yvonne.
But you've gone mute, so I don't know whether you're still talking.
Yvonne. Maybe you can go to the next question as she sets up. Maybe you can go to the next.
I think we cannot hear Yvonne clearly. Maybe we lost. It probably is network.
Yeah.
I don't know if there's anyone else who has a question. Has made her to get back.
Hi, Steve. Can you hear me?
Yes, I can hear you.
This is Liz.
Oh, okay, you're welcome.
Mine is a comment. Really, thank you so much. That was quite a huge summary of all what data science is about.
Okay.
So for me, that's just my comments. To really lots of work to summarize everything that it is, that is data science, even with an example. Thank you so much.
Okay, thank you. We are welcome.
Hello?
Hello.
How do people raise hands on this forum?
So you see, we are trying to use Zoom. There was a limit of period, the time required for any session. So that's why we resorted to this. But Zoom, I think, is a bit easier to use, and it can also facilitate that. But we can go ahead.
Yeah. So I might also have some small comment.
Okay.
I don't know how many of the guys in this webinar right now have a background in stats. But I noticed something. There was some bit of a struggle, like explaining the Y train, the X train.
Mm-hmm.
I just wanted to comment something. In stats,
yes,
the X variable is usually the independent variable, like the one you will use to find out the value of the dependent variable.
Yes.
Yeah.
And then the Y is always the dependent variable, the one without an IN at the beginning.
Yes.
So, well, for me, when I just look at X train, it just automatically clicked to me. X means the independent variables in the section for training data. Y meant the dependent variable for the training data. But you still did a good job to explain what it's all about.
Okay.
Well, I kind of it was a bit of a challenge for me because you in the demonstration you're using Python and I saw it like forever ago. Maybe I should brush up on it.
Okay, maybe what you are doing, maybe Thomas, that maybe Steve was in he did it first, but what we intend to do is that we need to provide introduction for R and also provide introduction for Python. So that as we go forward, we just be clear from what we are doing exactly. Yeah.
Then I have this other small question.
Yes.
Well, we were talking about machine learning.
Okay.
And let's say I go home and what will excite my kid about it, apart from I have to use a computer for it?
What will excite you?
My kid about it.
Okay.
I don't know. It's kind of a vague question, but I know people talk about machine learning. I'm not so sure if I see it in practice. I know the supervised part, the linear regression models and stuff like that, which are kind of everyday, but still, of course, my kid will not understand because it has limitations. Like the linear models, you can't predict outside the range of the X variables.
Okay.
But for the other unsupervised one, I'm more interested to see, like, okay, you mentioned about Netflix.
Yes.
But I don't even encourage my kids to watch Netflix. Are there better illustrations?
Yeah, sure. Like there's Amazon as an illustration on recommending prices and helping in suggesting prices based on how the trends and things are going.
Yeah. Also, another good example that many employers don't want to hear is LinkedIn. Yeah? When you were searching for a job, and then the subsequent search, you don't have to do the subsequent search. They just recommend for you if any company has advertised for a new job that is related to what you searched before, it just recommends exactly based on the search. Yeah.
Are Jumia using it?
Jumia exactly is using it. Yeah, it's using it. When, for example, for Jumia case, I don't know how it works. Maybe Evans has some knowledge in how. Evans has some knowledge on how it's done. But from what I see when I buy something from Jumia, they keep on, when I open a browser, they keep on giving me all these ads everywhere. Maybe Evans can chip in for Jumia.
Evans, is he there?
Yeah, he's there, but still.
Oh, he's muted. He has muted his microphone. Unmute your microphone first. Yeah.
Yes, Evans Young.
He has muted his.
Yeah.
Oh, sorry guys, I was muted. So I'm not very conversant with how Jumia does their recommend assist. But what I have dabbled with in the past is for recommendation systems is collaborative filtering. That is that is the technique that I've used when working with data sets to do recommendation. So maybe let me just type that in so you can have a look at it probably after the presentation.
Great, thanks. Maybe to quickly answer, I saw your question here. You said any reason why we used only training and test split as opposed to train, validation, and test. So for this case, yeah, you're right. Another way is, well, I just used it like as like the simplest case scenario, but still the best option actually to use apart from now, as I was saying, k-fold validation. This is another thing that is now being on use more to have even your model even better, splitting your data into 3: train, validation, and test. So I just use it like, well, an easier way to, like, well, if you're introducing something to us, because it's basically introduction, but then in advanced cases, this is how this should be done. Getting to Yvonne's question, thanks, Yvonne. Your question is quite good. I like it as well. Like, the description of data science, normally people are required to have, you need to have data science, engineering skill, data science, and things like that. And which these are skills that to build as one individual, well, it quite takes a lot of time and things like that, and based on your specialization. So to me, what I think and what I've seen, based on, especially on where I was, in Senegal where I was, so I've seen companies, like, for example, a company that I knew that was doing this very well was called Atos. It's an international, but its headquarters in Africa is in Senegal, Dakar. And what they were doing it for them, they were working with data science team, and then with the team now, we have people who are specialized when it comes to data science. Like, we have data engineers, we have they will have data scientists, they'll have, so like all these people, they have people who have specialized in different aspects, then they work collaboratively together. I think that is what is majorly missed, because having one person to build what we said in general, well, it's possible, but this will take time, and generally that is it. Like, having someone who can do really well in database engineering and everything, who can do very well in visualization as area of expertise, having like all this thing and domain knowledge as well, at times it becomes hard. And I think that's when a collaboration and working together as a team comes in handy. But I think normally the recommendation is, well, be an expert in one field, but also try now to learn the other things, just to at least complement what you are really good at. Yeah. And Thomas' question, you had talked about the machine learning. What can you tell your kid? To me, I look at it as like, it's an interesting way. To me, I look at it in an interesting way, in the fact that if it works well, the problem is that machine learning itself has flaws in itself, and it can perform very bad. But I think of it like, given a big data set, that it can go and do beyond what a human brain many brains brought together, to identify very minute and tiny patterns within the data by itself, and give you maybe good conclusions that are usable in real world case. Because the machine learning case has become usable and more important, as examples were being given on recommendation and things, that just based on the fact that as data is increasingly rapidly becoming big, and the machine learning algorithms are able to get deeper and perform even better when the data grows bigger and bigger and bigger. So, well, if it performs well, it doesn't fail. I think it's something that everyone will want to get into and jump into.
Yeah, thanks, Bam.
Yeah.
Okay, any other question or comment from the rest of the team? Okay, if there's no, maybe we'll go to another session just shortly for maybe next 5 minutes.
No,